Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The reaction involves a Stork-enamine-Michael addition. The enamine formed from cyclohexanone and 4-methylpiperidine, the 1,4-methylpiperidine 1-YL, cyclohex 1-Na, acts as a nucleophile in a Michael addition to the nitroquine electrophile. Moving on to the next step. 1,4-methylpiperidine 1-YL, cyclohex 1-Na is the enamine of cyclohexanone with 4-methylpiperidine. The nucleophilic carbon is C2 of the cyclohexene ring, the alpha carbon equivalent. Moving on to the next step. The nitroquine is E1-nitrobut-2-Na, which has the structure CH3, CH is equal to CH, CH2NO2. Wait, re-examining, the structure shown is Me on one end of the double bond and CH2NO2 on the other end, so the nitroquine is E4-nitrobut-2-Na, O2N, CH2, CH is equal to CH, CH3, i.e., trans 1-nitrobut-2-Na, nitromethyl on one carbon, methyl on the other carbon of the double bond. The Michael acceptor carbon is the beta carbon relative to number 2, which is the carbon bearing the methyl group, the less substituted end from number 2. And for the final step. In nitroquine Michael additions, the enamine attacks the beta carbon of the nitroquine conjugate addition. For CH2 is equal to CH, Me dash. Actually, the structure is O2N, CH2, CH is equal to CH Me. The beta carbon to the nitro group through conjugation is the terminal CH Me carbon. The enamine C2 attacks the carbon bearing the methyl group, the gamma carbon relative to number 2 beta to the activating nitro via the Vinylogous system. This gives a new C to C bond between C2 of cyclohexane and the CH, Me, carbon, with the CH2NO2 group remaining attached. After Michael addition, H3O+ work up hydrolyzes the iminium ion to give the ketone, cyclohexanone. The product is 2,1-methyl-2-nitrothyl, cyclohexane 1-1, i.e., cyclohexanone with a CH, Me, CH2NO2 substituent at C2. This corresponds to option B. Why other options fail? Option A would require attack at the carbon-bearing number 2 directly, wrong regiochemistry, and gemdimethyl pattern inconsistent with the substrate. Option C would require a methyl group at C2 of cyclohexanone ring itself, which does not arise from this enamine. Option D would require a nitroquine without the methyl branch, inconsistent with the nitrobutene substrate. Therefore, the correct answer is B. Therefore, the correct answer is option B.